Remember back a while ago, I started this project with the RC Power Wheels, like kids' toy power car thing. We were gonna make it into a remote control car. Well, today, we're finally gonna get that thing working. I didn't realize how long it's been. Last time we worked on that was in August of last year. And before that, it was probably another 4 months or something. I don't remember exactly, but time flies. The main reason it was taking so long is I was trying to find a differential or a dual motor differential drive controller to run that thing with. Originally, we were gonna try and use stock wheelchair electronics and make a remote control interface for that. I am still working on that, but kind of for a different purpose. I decided it'd be a lot easier just to get a remote control transmitter receiver and use a hobby motor controller. Unfortunately, most of those things are typically 300 bucks, and then you have to build some sort of interface and do a bunch of programming and stuff. Well, I was trolling around on Amazon the other day, and for 68 bucks, I found one. Here we go. This is a 60 amp, well, 30 amps per channel, dual differential driver motor controller. And the cool thing is, see these wires? It has 5 different interface methods on it. And you can literally just plug in a remote control receiver and it'll work. I've already tested it. It works. So now, today we're gonna be grabbing the Power Wheels car. It's out in the white van. And we're gonna do some wiring. We've got some batteries inside. We're finally gonna get this thing running. It's, yeah, time flies, like I said. So the other night I did a live stream on the other channel, hence the streaming desk here, and we unboxed this thing and did some basic testing on it. I powered it up using this 18-volt drill battery. These things can actually run on anywhere from 7 to, I think it was 39 volts, and it's got built-in power regulation to run your RC receiver, which is right here, and yeah, it's pretty sweet. We got a Fly Sky, one of these things. These aren't the best systems in the world, but the reason I got this one is it has a USB interface on the back and allows you to run custom firmware and do some other things on it. But the thing powers up, it works. We're able to control some random servos here. This was from the drone dropping mechanism I made a long time ago, but yeah, the FAA doesn't appreciate that this exists, so we'll call this a servo tester with a piece of wire attached to it. Anyways, let me get this thing wired up real quick, and then I'll show you that this does in fact work. Well, at least the lights blink on it, and then we'll work on the wiring. I'm waiting on a delivery from Amazon at the moment. It should be here sometime in the next hour or two, but it's a bunch of 40 amp heat shrink ring terminal connectors, because we need to use some good quality connectors on this if we're gonna have 30 amps per channel running through it. Yeah, I'll drop a link to this thing, Amazon affiliate link, of course, in the description down below. But these controllers are really neat, and I think I'm gonna get a whole stack of these things. And we're gonna, well, another thing I wanted to do is make this shopping cart remote control, and then also build a remote control lawnmower. I've been talking about it for a long time, and in that time, a bunch of other people have built them, but I still think it'd be cool to make. So, yeah, let me get some wiring done here, and I'll show you proof of operation. Okay, so the thing's powered up now. We don't have any motors connected, obviously, but what you'll be able to see is we've got some little data lights over here and then output lights to show that it's actually doing stuff. So as I move the stick on this forward and backwards, you can see these lights here showing that the motor channels are powering up, and we're getting data from the 2 RC channels here. So we've got left and right, forward and back, and I believe it's doing mixing on its own. Yeah. So out of the box, all you have to do is plug this thing in and you're basically good to go. Now this thing has a bunch of other channels. There's, actually let me unplug this. There's 6 okay. There's 6 channels on this thing, and that's gonna allow us to do a bunch of cool stuff like turning lights on and off, or maybe some sort of like Nerf cannon or water guns or something. This side over here is set up for flight mode, and it does like rudder and aileron mixing and stuff. But for now, all we need is this for forward and back, left and right. and we should be good. All right, I was trying to remember what the motor connectors looked like on this thing, and apparently I forgot. It's using the hover round style block connector, and the batteries just plug into this, and then the joystick plugs into here. We're not going to be using any of that, so I think what I'm going to do is flip this thing on its side, and then we might take apart this connector, or maybe... Well, I think I should be able to look underneath there and separate out the motor wiring. I don't think I'm going to destroy this connector because this goes with the joystick that I have, and these things are kind of hard to find, so I don't want to destroy it necessarily. I think it's one of those parts that's best left in stock for some purpose eventually. I've got the joystick that goes with that system right here. It's one of these ones with the giant cable that comes out of it, and the motor controller is actually built into this. We repaired this in a video a long time ago. If I can find it, I'll put a link to it somewhere. But yeah, here's the connector that goes to it. And then this is our charger connection. So rather than cutting this thing up, we're going to leave it be. And we're going to probably on the other side of that, we're going to cut the wire about down this far. That way we still have the whole setup in case we need it for later. I have absolutely no idea when I could possibly need to use a hover round style controller. But it's one of those old things, it's like considered vintage now, and I'd just rather not destroy it, so meh. I've got the thing sitting up on a piano dolly right now, but I am remembering that we're gonna have to do something about the steering in the front of this, because right now it's got sort of rack style steering where you turn this little wheel and that makes the wheels move back and forth. Obviously I'm not going to run an actuator to do that. Oh, we might have to power up the electronics in this thing. I think it makes noises and it has a horn. Yeah. Okay, so we'll work on that later. But I think what I'm going to do, I've got the back wheels for it, and I think the easiest way to make this work is just basically fix those wheels so they don't swivel anymore. Then we're going... Oh, the power just blinked. Oh man, I do not want to go with that power again. But like I was saying, we're going to saw off a flat part and make a hole, maybe about this big, in there. And we're going to sink a swiveling caster wheel into there. I'm going to mount it up inside so that as you're looking at the profile on this, that caster wheel just barely sticks out. And the hole will be big enough for that thing to swivel around. So essentially we're going to fix these in place so they don't turn anymore, lock them so they don't rotate, and then we'll have that bottom part sliced off. That way we'll still have the aesthetic of the wheel, at least, with drag slicks on the back, and it'll be able to turn. Because the way we're accomplishing steering is by turning one motor one way and the other way. And this motor controller handles that mixing internally, and I don't really want to screw with that or try to add some sort of actuator or something that makes it steer, so I think it's going to be the easiest thing to do for now. We may not get to that part of it today, but we're going to get this thing powered up and get it moving at least. I think it'll go somewhere around 5 miles an hour, somewhere in there. I'm not sure how fast these motors are, but some of the old single controller chairs like this thing has actually move pretty quick. But anyways, I'm going to pull some batteries out here, kind of poke around at a few things. Then hopefully by then Amazon will be here and we can actually get the harness made. Fast forward a few hours later. It's now 8:30 at night, and this was just delivered. Kind of interesting, the Amazon logistics trucks now are basically the same thing as a UPS truck. They're huge. But we've got here a 300-piece kit of assorted ring terminals. It was 17 bucks for all these, and they're supposedly heat shrink. Ah, nice. Yeah, so there's a bunch of large heat shrink a bunch of large ring terminals with heat shrink on the end of them, and let's see, 12 to 10 gauge. So that's good for like 30, 40 amps, something like that. Pretty substantial metal there. Looks like we've also got some spade connectors, some little forky looking things. Yeah, cool. I think this should work. Sweet. I needed something that was pretty beefy to use for the power input here, since we're gonna be having like 60 amps potentially flowing through this thing. But yeah. All right, it's the next day. which is indicative by these marks right here. I decided to just go ahead and cut the motor connectors off of the harness on that other setup. I left myself enough wire so I can use that later for other projects if needed. But what I've done is I've peeled off the little protective housing that it had, and we're left with these two connectors here for the left and right motors. We've got two very heavy gauge wires here and two thinner wires. These thinner ones are for the brakes. Those run in parallel. It's either 12 or 24 volts for the brakes on this. I'm not sure which right off. We're going to be mechanically defeating the brakes, however, just for now. I'll show you how I'm going to do that here in a bit. But I've gone ahead and wrapped these wires back on themselves and made a little loop here just so they don't get in the way. Now, I'm using some thinner gauge wire here for the main controller. This stuff, honestly, is probably thinner than it should be. This apparently is, since it's PWM, it's 30 amps. I think when I looked at it previously, someone got confused and they're writing the description, and they just added the two channels together and said, oh yeah, that's 60 amps. PWM though, not so much. We're going to be hooking current sensing up to this to test everything and make sure. I think we're going to be okay though with this smaller gauge wiring, even though in theory we're only pulling 30 amps per channel. Well, that is the max. But the thing to remember, this little Power Wheels car doesn't weigh 100 pounds. And no one's going to be sitting in it. So, we shouldn't be pulling that much amperage, which means I think we should be okay with the smaller wiring. We'll definitely see for sure, and I'm going to do some testing right away. But, right now what I'm going to do, I need to dig around and find some more bulk wiring that I have. But I'm going to, I dropped one on the floor. I'm going to take these two little connectors, wire them up with a harness, and then we're going to get them plugged in and installed down here. There isn't a whole lot of space in here, but we've got one motor connector here and the other one down here. And these actually have, I don't know if you can see here. Yeah, see this guy right here? This is like a big RF choke. So, in theory, I mean, we don't really need that. I'm not going to take them out, but, you know, we've got some filtering, air quotes, as it were. But I'm gonna get these two connectors set up here and get the wiring set up. I drilled a small hole down here that goes through to the top side of this car. Ah, there it is, right down there. I'm gonna get the wiring worked out, get it tied up on the bottom so I don't need to do anything down there anymore. Then I can flip this thing back on its top. Then we can work out getting the batteries laid in here and getting the controller hooked up and figuring out where to mount everything. I just got out of bed a little bit ago, so I'm easing into this today, and I still see no reason why we shouldn't be able to get it going. All right, some time has passed. I was getting ready to go to the hardware store to get some cable because I didn't have any suitable gauge double conductor wire to connect these motors to the controller. But then I remembered that ozone generator that I stripped a bunch of parts out of, I'd cut the power cord off of it, and it wasn't grounded, so I'm not going to be using it for anything else, but it was the perfect cable. Now, I may have gotten in the zone a little bit when I was building these adapter harnesses. We've got the motor connector on this end with the loop for the brake actuators if we need those later separate. And then we've got, oops, still have tape on there. I used a bunch of the wiring harness sheathing stuff to coat the whole thing. But we've got our heat shrink connectors here on the end to go to the controller. This part goes to the motor. Did one of them in yellow and the other one in red. By the way, thank you to the person that shall be unnamed that sent me this this box of stuff. I think it's been a couple years ago now. Anyways, boxes of random stuff like that come in super handy. But yeah, we are super close now. Basically all I need to do is get these connected to the motors, route them up through the inside, and then figure out where we're going to mount this controller and get the batteries in. I love how to me that seems close. Anyways, I'm going to keep plugging away at this. I'm probably going to get some lunch right now, and then we will pick this back up in a little bit. I'll see you in a split second. All right, we've got our wiring in the bottom there, and it comes up through that hole, and then we can connect our controller to this. I still need to vacuum this thing out. It is filthy in here. But right now what we're going to do, as you can see when I push this, it doesn't want to move. That's because our brakes are on. Now these motors have gearbox neutrals instead of brake neutrals, so mechanically defeating these, I might just completely take them out of there. I don't know, we'll see. I'm gonna get this cover off, and then we'll see what's involved here. Oh, look at that. That's actually cool. They have a thermal pad in here with heatsink compound. I have never seen that on a wheelchair before. Wow, that is neat. Huh. Well, there you go. Learn something new every day, I guess. I mean, I know these coils get hot and everything, but yeah, I've never seen a thermal solution like that before on these things. These are some very hefty brakes. That's crazy. Wow. So I think the easiest thing to do here, since I don't want to cut this wire, I think all I'm going to do is take this plate off of here and then remove this friction material that's in here and then bolt the whole thing back on. I guess the other option could potentially be... Actually, removing this might be a lot easier. Let's see. Where's my Allen keys? Yeah, let's see if we can remove this little guy. I think that's going to be our path of least resistance to defeating this brake system. That way the motor shaft can just go in there and spin. It doesn't really matter what's going on. Let's see, looks like there's only one set screw. All right, let's see if this will come off. Sometimes these are pressed on and they're not coming off without a fight. Yeah, that doesn't want to come off. Let me try something. I'm going to try heating this up with the butane torch here and see if we can get it to pop off. Yeah, we're not getting any movement on that. Oh wait, is it threaded? Sometimes these things are threaded on here also. Hang on, I'll be back when I figure out how to remove that. But you can see here, it's hot now. Oh, there's two set screws. No wonder. All right, let's see if that made a difference. Hey, look at that! Of course, for some reason, this thing is scalding hot now. Hey, there we go. That'll do. Now we just have to jam this thing back on here and we are good to go. Okay, we've defeated the brakes. Now, as you can see, well, not easily, but it will roll around. Now there is one thing we have to be really, really careful about. These are brushed DC motors, which generate power when they're turned manually. Now, this motor controller that I got, well actually most motor controllers, do not have output protection. Problem is, if voltage comes back in through the output drivers, it can blow things up. Now, typically, some motor controllers may include output protection, but I think in most cases they kind of rely on the person that's building them, since every application is different, to think about the protection circuitry that would be needed, which I think would probably just be some diodes, but there's someone else I know that is much smarter about motor controllers and DC drives and PWM switching and stuff. I'm going to send them a message and see if we can figure out what's going on here. I'm going to give them the specs and see if it is necessary. I think for right now, I can probably get away with testing it because this thing isn't heavy enough to roll on its own and there's no hills out here. So I'm going to see what he thinks and see if we need to do anything for now. I think if nothing else, we should be able to power it up and move it around a little bit. I'll just have to make sure. I may install some switches or some connectors so I can disconnect the motor driver if I need to push the thing around. Because, yeah, I don't need to explode that thing. And that's not covered by any sort of warranty, so yeah. Actually, I'm somewhat curious what our feedback voltage is going to be on this thing. So I've connected this meter up to one of the motors, and I'm going to push on it a little bit and see see what our voltage is here. Okay, so that's like 1.5, maybe 1.5 volts at a pretty low speed. Okay, so that got up to 3.7 volts. Now, that took a lot of force and it was moving pretty quick. My only concern is when I let off the throttle, if the thing is going to coast or not. But I think it's light enough that it won't. I believe if this thing is moving and the output to the motors is turned off, those tires will probably almost more likely skid than anything else. And the controller does have regenerative braking built in. So that's going to work as a brake as well. Anyways, I just want to check some of this stuff out. I think we're going to be okay for now without putting output protection on the driver. Just for testing purposes. We're going to make some more refinements to this as we move along. And also, I'm going to do a completely separate video linking the RC controls of my wheelchair joystick to be able to drive that thing. So that's going to be kind of fun. I'm not going to make any promises as to how soon that's going to be, but we'll at least get this thing running for now. And yeah, so I'm going to get the batteries in here. I'm going to get the controller mounted up, and yeah, hopefully we can go for a rip here shortly. All right, some time has passed, and we're ready to power the thing on. I wanted to do it on camera just in case it fails spectacularly, but allow me to show you the setup. I cleaned some of the filth out of here, but yeah, there's still like a bunch of rust from that old battery charger down there, and we can get rid of all that. But we've got our little PWM controller here, and that's connected over to our RC transmitter. I used some black plastic drinking straws and just hot glued those on there so we could have the antennas pointing upwards. And then we've got our Duracell batteries down here. I've got quick connects on everything. These are running in series. So we should have 24 volts. Let's see, we've got red. So blue is our positive. And then our negative's over here. And then our crossover is here. And all I have to do is put in this fuse and it will power up the system. I only have a 20 amp mini AT style fuse. It might blow instantly, but I don't know. We'll see what happens here. You ready? Actually, kind of nervous. Actually, let me set the camera down. Let's see here. All right, here we go. Fuse installation. Okay, we had a bit of an arc. It didn't blow though. And it looks like our controller is powering up. Get some blinking lights over here. Okay, our receiver's on, so let's go ahead and fire up our transmitter here. And looks like we're connected. I'm going to set you guys down over here for this. Now, I don't know if our channels are correct or what's going to happen, so I'm going to go over here. And where's my wire cutters? I'm going to grab the wire cutters. Okay, I've got our wire cutters in case things get out of control here, so let's see what happens. Oh my gosh. Okay, this thing is way too sensitive. I'm gonna have to change the programming on this controller. Holy crap. It seems to work though, and their regenerative braking makes it just instantly stop. I think we have enough traction that it doesn't matter that the front wheels don't turn. Look at this. Like, that's just no problem. Okay, so our left and right axis is swapped. So what I need to do is swap the left motor for the right motor. And that'll fix that. But I think for now... Oh boy. Oh my gosh. Uh-oh, something's not happy. Oh, we powered down. I wonder if we blew the fuse. Oh yeah, blew that fuse to smithereens. Oh, this is outstanding. Okay, give me a little bit here. I'm going to check into the programming on this controller and swap our left for right and see if I can find a bigger fuse. Oh, also, I need to install our amp gauge on here. I forgot to do that. So this is one of those things that you know is going to be interesting, but when you actually see it happening... It's outstanding. This thing is so snappy. Okay, so I'm going to do a few things real quick. I'm going to cut some pieces of wood to stabilize these batteries because they're flying around in there. So I'm going to cut some 2x4s and 2x6s and stick them on each side there. We're going to find a better fuse, and then I'm going to swap our left for right motor. That way our drive output is working properly. And yeah, I think we're having fun now. All right, I found a 30 amp fuse and stuck it in there. And then I've also got our current monitor on here as well as a voltage monitor, so we can keep an eye on how much amperage this thing is actually using. So it looks like 4 amps. Yeah, so that thing doesn't update super quick. I'm going to play around here a little bit more. I think it's dark outside. Yeah, it's like almost 6, and I think it's raining. But yeah, I'm going to play around with this. Well, I'm going to play around with it a little bit more, and then I'm going to get some more footage of this thing driving. I'm going to fix a couple of little things on it, and then we can run around for a little bit at least, and you guys can see how it works. We're definitely going to be doing more stuff with this in the future. This thing is too awesome just to build and then never use again. I've been in the garage all day and I haven't looked outside in a while. I assumed it was dark, but as it turns out, it's not. Oh, so I kind of forgot I didn't have to change any wiring, and also I was able to tune the throttle curve on this thing. So I think we should be... Oh, I didn't save it. Okay, I'm going to make some changes real quick. Okay, so that was maybe 50% throttle, and we were at about 25 amps. So, yeah, I think we need to get bigger fuses. Or maybe even circuit breakers. Yeah, we definitely need to address that steering issue. It's going to rattle that thing to death if we keep doing that. Also, I've been noticing the motors in the back need to be tightened up or braced up a little bit more. They kind of move around. All right, so what have we learned with this brief test run on this thing? There's a few things that need to change. First and foremost, this entire thing is made out of plastic. And it's got these doors that open. It's got little door handles that usually work. So we've got a lot of torque back here, and this is our only frame here. So we've got a lot of torsion on the back half of this thing. Now the door on this side's broken. I actually hot glued it shut because it wouldn't stay. So I think what we need to do is beef up the inside of this thing. I'm gonna have to run some struts from up there clear into the back, and then also maybe put some angle or flat bar. Well, I'll probably put flat bar on the bottom and then put some tension on the top here with some turnbuckles to really rigidize the back to the front of this thing. And then also, I'm gonna have to figure out with the motor mounting, because I know it's been forever since the last video, but I'm using some plywood things that are sort of mounted on the plastic inside here. Actually, you can see. Yeah, so the motors are mounted right underneath here on each side on these little plastic things. So we need to add a little bit more bracing down in here as well. And then also we're gonna have to figure out what we're gonna do with the front wheels on this. I think my plan before with cutting out the bottom of the wheels and getting some rubber casters to put in there and then just locking the steering. Oh, should probably turn this off. Yeah. Installing a switch would probably also be another good thing to do. But yeah, I think locking the steering and just putting caster wheels inside those. I want to get rubber ones though, so we don't get that hard plastic rattling. But yeah, I think this thing is going to be really cool. I got the throttle turned down to about 70% and we're pulling maybe 25 amps. So that's probably good. The controller though, it never even got, how do you say that? It never got the chill off of it. It's still cold to the touch. It didn't heat up at all. So we're not stressing this setup in any way. Then obviously I'll want to clean up some of the wiring and stuff. And build some proper wooden spacers for these batteries and strap them down. Right now there's just pieces of plywood and 2x4s jammed in there, which works, but yeah. This thing may not be stupid fast, but it's something that people, I mean, I don't know, I'm sure people have built them, but you don't see them every day. This is going to be sort of a hobby project moving forward here and there. I've got a bunch of RGB lights, like I said, I want to add in there. And then we've got 4 auxiliary channels we can use for other things. So, yeah. So I think at this point, we're going to call it good. The thing works. I need to do some tuning. I need to download the software on it, change the regenerative braking curves, adjust the resistance for the motors and all that stuff. Because I'm sure out of the box, who knows what this thing's set to. And this thing seems a little more jumpy than it probably should be. I did reverse the axes with the controller, so I didn't have to change any wiring. That was nice. But yeah, I've got a bunch of RGB lighting we're going to add to this thing. And also I'm going to work on being able to control it with the wheelchair joystick using the PG Drives technology input-output module. That's going to be later on. But yeah, this is just so awesome. It reminds me of a soccer chair. Oh yeah, and by the way, if you look at the controller, you can see it's got feedback lights showing everything that's going on there. So you can tell when there's output and everything, which is pretty cool. All right, well that's enough screwing around for now. We will be picking this up later, and sooner than later, I might add. This is so awesome.